Okay, so this is the first of the video lessons. This one is on solving systems of equations. This should be a topic that you've seen before in other math classes. Specifically, you've learned about graphing, solving systems via graphing. That's when you graph multiple systems and where they intersect, that was the solution. You have substitution method. That's where you would solve for either x or y, and then after that, you plug it in. And then you had elimination method. That's where you made it so that the two equations would eliminate with each other. And there's a new method that I'm going to be adding onto this called matrices, and this is the focus of the unit, is matrices. So if we have two lines intersecting, so let's say we had two lines like this that were intersecting, two lines that are intersecting right there, we would have a total of one solution. Whereas if we had parallel lines, if I had two lines that were not intersecting, if I had two lines like this, we're going to pretend that I drew those perfectly parallel, there will be no solutions. Last option would be, what if I had a line that was right on top of another line, those two lines being exactly on top of each other? We call that infinitely many solutions. We call that infinitely many solutions. This solution set where there was only one solution, where the lines intersected, we call that consistent independent. We call that consistent independent. Where there were no solutions, where the lines were parallel, we call this inconsistent. And last but not least, where we have two lines interacting, two lines that are literally right on top of each other, we call this consistent dependent. We call this consistent dependent. So, my hope is that you all have seen solving via elimination before. So this is where we use multiplication, property of equality, to create the additive inverse of one variable. We're going to rewrite them so that the values of either x or y are exact opposites, add the systems together, and then solve for the remaining variable. But here's what I mean by it, okay? So here I have 3x minus y equals 7 and 2x minus 5y equals 9. I'm going to purposely try and get it so that the y's reduce in this question. I'm going to think of this equation here as my equation 1, this equation here as my equation 2. To make it so that the y's would reduce, I would need to multiply equation number 1. I'm going to show that by doing a 1 with a circle around it. I'm going to multiply equation number 1 by negative 5. If I do that, I would get negative 5 times 3x is negative 15x. I have negative 5 times negative y is a positive 5y. And negative 5 times 7 is negative 35. I'm going to copy down the second equation just exactly how it was. I have 2x, I have negative 5y, and I have equals to 9. All I did was copy down my second equation. I didn't edit it at all. Well, now what I'm going to do is I'm going to add these two equations together. Here's how I move this. Negative 15x plus 2x is negative 13x. Positive 5y and negative 5y, that would just give me 0y. And last but not least, negative 35 plus 9, that would give me negative 26. I'm actually almost done solving this. I'm just going to divide negative 13 to the other side. So divide negative 13 to the other side, and we get x is equal to positive 2. To get our final answer now, I'm going to plug 2 into the first equation. So I have 3 times x, remember x was 2, minus y equals 7. 3 times 2 is 6, minus y equals 7. Subtract 6 to the other side, I get negative y equals to positive 1. And then divide the negative, I get y equals negative 1. For these solutions, we do need to write them as a point. So it would be 2 comma negative 1 as a final solution. that was elimination. I now want to show you what inconsistent and dependent systems would look like. So this here was a situation where we had two lines intersecting. What if I didn't? What if I gave you this? I have 6x plus 3y equals 14 and 2x plus y equals 5. I'm going to still do elimination. I'm going to take my second equation here, and I'm going to multiply it by -3. I'm going to take my second equation and multiply it by -3. So I'm going to leave my first equation, my equation number 1, I'm going to leave exactly the same. It's going to be 6x plus 3y is equal to 14. My second equation, though, I'm going to multiply it by -3. So I'm going to do -3 times equation number 2. And if I do that, I'll get -6x minus 3y is equal to -15. I'm going to go ahead and add these two together. Positive 6x plus -6x is 0. Positive 3y plus -3y is also 0. And 14 plus -15 is -1. Well, no one believes that 0 equals -1, right? And since these are creating a false, a not true statement, these are parallel lines. These lines are parallel. There is no solution to this. These are inconsistent. So that's what an inconsistent system would look like. We have an answer that just comes out false. I'm going to change the numbers just slightly, and I'm going to solve this by multiplying the top equation by 2. So I'm going to take 2 times my equation number 1, and that would give me 3x times 2 is 6x, -y times 2 is -2y, and 2 times 4 is 8. I'm going to copy my other equation down. I have -6x, I have plus 2y equal to -8. And now when I add these together, when I add these two equations together, -6x plus 6x is 0, -2y plus 2y is another 0, and positive 8 plus -8 is 0. I get 0 equals 0. I know this looks similar to the last problem, but the truth is 0 does equal 0. This is a true statement. So this is when we have one line literally right on top of another line. This is a consistent set. This is consistent dependent. This is consistent dependent. So this is consistent dependent. This is when we have this is an infinite amount of solutions. Well, you know, we don't have to just stop with linear systems, right? What if we were to look at something a little more interesting? What if I were to have x squared plus y squared equals 16 and y equals x squared minus 4? Here I have two systems that are very similar, but not exactly the same. The very first thing I'm going to do before I even start trying to solve this, I'm actually going to subtract this x squared here to the other side. Oops, x squared. I'm going to subtract this x squared here to the other side. And the main reason I'm doing it is I kind of want all my x's and y's on one side and I want my number on the other. So if I do that, I'm going to copy my first equation down that said x squared, it said x squared plus y squared is equal to 16. And here I have, and I'm going to rewrite it in kind of a weird way, I have negative x squared plus y is equal to -4. All I did was put my negative x squared as the first term here. If I add these two equations together, the x squareds will cancel. I'm left with y squared plus y equals to 12. Be careful, I cannot add the y squared and y together. They are not like terms. They don't make y cubed or anything like that. But I can subtract the 12 to the other side. I get y squared plus y minus 12 is equal to 0. And this is actually just a factoring question. We can factor this. This is just times y minus 3. We set each piece equal to 0. I get y is equal to -4. And I get y is equal to +3. So I get y is equal to -4, and I get y is equal to +3. Unfortunately, we're not quite done. Those are the two y values. We now need to find an equation that we think would be easy enough to plug them into. And in my opinion, that would be equation 2. Remember the equation that went y equals x squared minus 4? Well, I'm just going to plug one of these y values in. I'm going to do negative 4 first. So I have negative 4 equals x squared minus 4. I'm going to add the 4 to both sides. I'm going to go plus 4 on both sides of the equation. And I get 0 equals to x squared, or x is equal to 0. So that means I got the solution of 0, negative 4. But that's not my only solution. That came from the y equals negative 4. We now need to do the same thing where y is equal to 3. So I have 3 equals to x squared minus 4. Add 4 to the other side. We get 3 plus 4 is 7 equals x squared. And if I want x by itself, I need to take a square root of both sides. And I end up with x is equal to, and this is where I gotta be a little careful, plus or minus the square root of 7. So what that means is that this actually creates 2 points. This creates the point positive root 7, comma 3. It also creates the point negative root 7, comma 3. And so all of these would be our solution. What we're saying is that this is intersecting 3 times, which kind of makes sense if you think about it. As we know, x squared plus y squared equals 16. That's just a circle. And then y equals x squared minus 4. That's a parabola. What we're saying is that this is intersecting the circle at 3 points, which kind of makes sense when you think about it. It is the parabola and the circle are intersecting 3 times. Okay, one more question left for this video. We're going to skip this problem. This problem here is a graphing calculator one, but the point is that you could plug both these into a calculator and the calculator could tell you where they intersect. But let's go to this problem here. Here we have y equals x cubed plus x squared minus 6x. And here we have y equals 2x minus x squared. Well, you might notice right away in both of these equations, they both say y equals. So since that's the case, I'm just going to set the two of them equal to each other. I have x cubed plus x squared minus 6x. I have x cubed plus x squared minus 6x is equal to 2x minus x squared. All I did was set the right-hand sides of both these equations equal since they were both equal to y. I'm going to go ahead and get all the x's onto one side. So I'm going to move the 2x and the negative x squared over. And I'll end up with x cubed. When I move this x squared over, I'm going to add it to the other side. So I'm going to add over here. So if I do x squared plus x squared, that'll be a 2x squared. When I move the 2x over, I'm going to subtract 2x. So that's going to be a minus 8x. And this is equal to 0. From here, I'm going to look for a greatest common factor. I have x cubed plus 2x squared minus 8x. I think I could factor an x out of all 3. We can factor an x out of all 3 of these. We end up with x squared plus 2x minus 8 is equal to 0. This factors, so we get x times x plus 4 times x minus 2 is equal to 0. And almost done. We now need to set all 3 of these equal to 0. So I get x equals 0. I get x equals negative 4. And I get x equals to positive 2. So we got 3 values for x. Does not mean we're done though. We now need to get the values for y. To do this, we're going to pick the equation we think looks better, looks easier to plug numbers into. I'm thinking this bottom equation. I'm thinking the bottom equation of y equals 2x minus x squared. And I'm going to start when x was equal to 0 first. I think that'll be the easiest one. So I'll get y is equal to 2 times 0 minus 0 squared. 2 times 0 is 0. 0 squared is 0. Hey, look, I get y equals 0. So when x is 0, y is 0. So I get the point 0, comma 0. That is one solution. I'm going to do the exact same process now, but when x was equal to, I'm going to do 2 next. So we have y equals 2 times 2 minus 2 squared. Because I'm still using 2x minus x squared. I'm just plugging 2 in for x now. 2 times 2 is 4. Minus 2 squared is 4. Hey, look, I'm also getting 0. So that means I'm getting the point 2 comma 0. Almost done. We need to do this one last time, but this time with negative 4. So I get y equals to 2 times negative 4 minus negative 4 squared. 2 times negative 4 is negative 8. Minus negative 4 squared is positive 16. Negative 8 minus 16 is negative 24. I'm getting the final point of negative 4, comma, negative 24. And all three of these would be our solutions.